Okay, now packaging grid is used to work out what parts of your product, how the product should be packaged, what components it's required. So for example, a packaging grid, you're looking at the functions of packaging. There's 4 basic functions. There's containment. Does the package contain the product adequately so that it doesn't leak or doesn't spill? Then you've got protection. Does the package protect the product? And then you've got functionality or convenience. Does the package work? Is it easy to use? Can consumers use it? Can it be easily filled by the manufacturer? And then you have the communication function. This is all the information that needs to be on the pack. So that's kind of like, these are the functions. The other part of the grid are the environments in which the packaging works. So the first environment is what's called the physical environment. This is the environment that when you transport the product, when it gets carried, when it gets moved, it's in the physical environment. It can be dropped. When it's in a car or in a truck or a train, it gets vibrated, and the vibration, if the product isn't protected properly, it can get damaged from vibration or shock. Then you've got the ambient environment. This is the environment we kind of live in, the breathing. So it's the temperature, it's the relative humidity, how much moisture is in the air. Is the product being frozen? Can the packaging withstand the freezing temperature? Does it have to have an atmosphere with oxygen or without oxygen? So you've got to try and remove that oxygen from or you've got to be adding it. So this is particularly for foodstuffs that becomes important, and also does it protect the product from any microbes or dust? If it's an electronic product you're working in, you might be just protecting it from moisture, but then you've got electrostatic charge that you might have to protect, because if an electronics good gets a charge in it, then it can actually destroy it. Then you've got the human environment. The human environment is the environment in which we interact with the package. Can I open it? Once I've opened it, will it leak? Or do I have to use it all at once? Is it easy to open? Is it easy to reclose? And so on. So that's kind of ease of use. So those are the 3 environments and the 4 functions. Putting them together in a grid, we now look at that grid for your product and you say, okay, it's got to contain the product, but it only has to contain it in the physical. We don't have to worry about the human, we don't have to worry about the ambient. But another product might be a powder, and that powder has to be contained in the ordinary physical environment so it doesn't spill, but it's got to be in the ambient environment too, because if that package goes to a high altitude, will it blow up like a balloon and explode? So the seals have to be enough. And then when I open it, can I reseal it? Or do I have to find another container, or will it spill? So suddenly all 3 environments have requirements. So you just work your way through the grid, filling out what's required in each of the grids. And you're allowed to be a little bit inventive about it. You don't have to just follow the rules exactly. And so then when you start designing your packaging, you've got key things you need to fill in and need to meet. Unless you meet them, your package won't do the job. Now you may end up with compromises. So there may be a case where there's one thing that you've got to do to protect it, but it functionally doesn't quite do the job properly. So there may be a compromise. And the other compromise, which isn't written into this, is the cost. How much is it going to cost? Because you may end up with a package that does all the things you want it to do, but it's so expensive you can't afford it. So you therefore have to alter it slightly. And the other one that's worth considering at this stage is also what happens with the product when it's finished. What do you do with the package when it's finished? Can it be easily recycled? Because that's a real important consideration today here in New Zealand. Now, there's a website that you can go to. It's called packaging.org.nz, and on that are some guidelines on how to develop packaging. You might want to go and have a look at those as well. Okay, so you want to develop a food product. Now, there's 2 major things that I find with developing a food product that you've really got to put together at the same time. So one, you've got to work on your formulation. Now, for a lot of us, and I know I was in that case, I love doing the formulation bit. And so I'd end up with food, but no package. And quite often the package actually takes more effort to design and more effort is often more difficult than the actual food product itself. So really, if you're designing a food product, you really need to do both the food product formulation and the package design at the same time, so that they run in parallel. And you've got to, with food products, once you've got a base formulation, you've got to go and try it out. Let the people eat it. Do they like it? Is it too sweet? Who's your target market? One of the things that I've seen sometimes is that we end up with the students who are making a product only for themselves or for their own age group, where in reality the product may actually be better suited to an older age group. You've got to go and find that older age group and try it out with them, you know. And then when you're designing the packaging, can they open it? Go and get your grandparents, your great-grandparents. Can they open it? Do they like the product? So, you know, widen your scope. There is a big audience out there, a large number of people who are not in your age group, and they may well buy the product. The other thing to remember is that who's got the money? Who's going to spend the money on these products? And so, you know, while you might develop a fantastic product for your age group, there may be a slight change to that product and you open up a whole new market.